Okay, guys, so today is our outline that I'll give you for the derivative quiz when you write that. You guys might be working on your hand in or whatever, but when you get ready to write the derivative quiz, it'll be a 25-point quiz and it'll have the following parts to it. So, first part of the derivative question one, you've got 10 points. Finding the derivative using the appropriate rule. Okay, and answers can be left in factored form. Okay, and you can bring in your derivative formula sheet that I popped up with the handout. Remember, I forgot to put the slope of the line equation on there, so you can add that in there. When I typed it in and I scanned it in, I guess I could redo that, but the slope of the line one, you can throw that on the quiz. So in this 10 points, you'll have 5 different derivatives. Okay, so you're going to have straight power rule, application, and then you also have a power rule where you're going to have to manipulate the equation, like convert from root to exponent form or something like that. Okay, and so study that a little bit. Then you can also have a product rule with 2 expressions. Okay, and then you have a product rule with 3 expressions. And then you'll have a quotient rule. And that'll be the first one. First type of question. And a quotient rule. Okay, so let's just do a couple examples of this using my marker here. So just to review a little bit. Okay, so straight power rule. Okay, so if you had y, oh, I hate that. Got to set it so that it's skinny all the time. Okay, so all of these different types of ones. Let's just probably the hardest type in here would be maybe a quotient rule or a 3 stage power rule. Okay. Again, if I look back here, you may bring in your formula sheet, which looks like this. Okay, keeping in mind that I forgot to put the line equation, so you might want to write it on the bottom here. Y minus y1 equals m times x minus x1. Okay, so let's do an example. I'm not going to do all 5 of those. Those are basic applications of these rules. Let's do the quotient rule one. Let's do a quotient rule example, just to do an example here. So say something like you would have a y equals, I don't know, 6x squared plus x all over 9x cubed. Okay, so if you're doing the quotient rule, we know the quotient rule is f g prime minus, where is it here? Minus f, let's see what I got here. F prime g, obviously, over g squared. There we go. Okay, so if we take f being 6x squared plus x, f prime, using the power rule, would be 12x plus 1. And then if we do g equals this, g prime is going to be 27x squared. Okay, so if we apply the product rule that we have here, f times g prime, so that's 6x squared plus x, all times 27x squared, minus, okay, f prime was 12x plus 1 times g, which was just 9x cubed, okay, all over 9x cubed squared. That's our derivative. Now, this one's simple to simplify because it's only distribution here. So you could simplify it if you want. So 27 times 6, I'll do that quickly here. 162 x to the fourth plus 27x cubed minus 12 times 9 is 108. So that's 108x to the fourth. Okay, and then plus 9x cubed. So we can simplify those because they're common ones. All over 9 squared is 81. And x cubed squared is x to the sixth. Okay. And then if we want, we can simplify this by subtracting those two. So that would be 162 minus 108. That gives us a total of 54. X to the, what is that? Fourth there. And then we've got 27 and 9 plus 36 x to the third over 81 x to the sixth. Okay, we can take out a third, 3 x's each because there's a cube there, there's a cube in there, and there's a cube in there. And then 54, 36, and 81, I think all can be divided by 3. That'll be 18, 12, and 27. Oh, divided by 6, actually. Or maybe 9. Yeah, 9. It can be divided by 9. So if we reduce that 9 into this, 6x, 9 into this, plus 4, because that we're taking out the x cubes as well, over 9 into that, 9x cubed. That would be it reduced down. Okay, obviously I'm going to have the rule that you just have to leave it in factored form. So you could have left it here and I wouldn't have marked it wrong. But if it's simple to simplify like that, go ahead and do it. So there, that's 10 points. That's a 10 out of 25 points on your quiz. Okay, so let's go down to question 2 here. Okay, what does question 2 entail? Well, question 2 is chain rule stuff. Okay, so question 2, I'm just going to look here to make sure I get it right, is the application of a chain rule. Okay. And that's just worth 3. Okay, so you're going to be using the chain rule here, this idea right there. So let's go ahead and do an example of a chain rule that you would see. So let's say y equals I don't know, let's say 2/3 square root of 9x to the 4th minus 8x squared plus 12x all let's see if I do a 3. Yeah, let's put it to the third so that we can have a reduction to the third. Okay, so if we have to do the chain rule here, okay, the first thing is we'll rewrite it. It's equal to 2/3, and this is 9x to the 4th minus 8x squared plus 12x. Okay, and we're going to do the exponent. This is square root, so that goes in the denominator. This goes in the numerator, so 3/2. Okay, that's kind of why I put the 2/3 in front. So now we're going to apply chain rule. Now you can just apply it and write it out, but if you want to use variables, we can say that u equals 9x to the 4th minus 8x squared plus 12x. So that means du dx, derivative of u with respect to x, is 36x cubed, 4 times 9, minus 16x plus 12. And then we have this as being y equals 2/3 u to the power of 3/2. So now we have to do dy du. Okay, so that's going to be this times this, so 2/3, I'll write this one out, times 3/2 u to the 3/2 minus 1, and 1 is 2/2, so that'd be 1/2. Okay, so then this is going to equal 6/6. It's going to be u to the 1/2, because 6/6 is just 1. And then we have to do the chain rule now. We have to do dy du times du dx to get dy dx. Okay, so we'll do that, and we'll place this value in for u now. So that'll be 9x to the 4th minus 8x squared plus 12x. Okay, and that's the power of 1/2 times this stuff, 36x to the 3rd minus 16x plus 12. Okay, you could write this as a root if you want. Okay, and I wouldn't bother, this would be square root of all that and then times that. Okay, so that's an example of a chain rule. I have one of them on the exam. Okay, then I have a combination rule for our next question number 3. So let's flip ahead. Okay, let me just get my timer out here so I see how long I'm doing this. Okay, we're at about 14 minutes. I don't want to spend too much on this. Maybe half an hour today. Might be a little longer. Okay, question 3. I'm going to give you using combinations. So you're going to do the chain rule and product or chain rule and quotient. I'm not going to give you both of them. I'm only going to give you one of them. It's worth 4 points. So keep an eye. You could do a chain rule quotient, chain rule product, either or. Using a combo. So it's either going to be a chain with a product or a quotient rule. Change it up year to year. Sometimes use the same exam. Sometimes I change it up a little bit. Okay, so let's do one that uses a product rule. Let's say that we have something like y equal, I'll leave in factored form, of course. That's 4 points, by the way. Okay, so y equals, let's say I had, I don't know, 2x minus x squared to the power of 3 times the root of 5x minus 2x squared. Okay, so this would be, if we write this out, in exponent form. Okay, there is our equation. So f equals 2x minus x squared to the power of 3. So we got to do a chain rule to get f prime. Okay, so we're going to take 3 out front, put the brackets as our variable, 2x minus x squared, subtract 1 from the cube to get squared, and then chain it with the derivative, what's inside, times 2 minus 2x. Okay, we'll do a little simplification there. 3, let's multiply that in the brackets there. 3 times 2. Oops, sorry, I want to erase this. I'm going to multiply the 3 times the 2 minus 2x and put it in brackets. So that'd be 6 minus 6x in brackets times 2x minus x squared all squared. Okay, so that's our prime for f prime. And then g is simply 5x minus 2x squared to the power of 1/2. So if we get g prime for this, we're going to have to take that 1/2 out front, put the variable or the bracketed term as our u there, subtract 1 from 1/2 gives you a negative 1/2, and then multiply it by the derivative inside, which would be 5 minus 4x. Okay, and to reduce that one, I'm going to write it like this. 1/2 5 minus 4x times, and I can times this or put this on the bottom if I want, right? Because it's so we're going to say, but I'll just leave it as an exponent form because that's traditionally what I like to do. Okay, and then we just apply the product rule here with using what we have for our expressions of f and g and f prime and g prime. So it's going to be, we're doing the product rule again. You can look on there. It's f prime, f g prime plus f prime g. F g prime plus f prime g. That's the way I'm going to do it there. So f is 2x minus x squared to the third power, and then g prime is 1/2 5 minus 4x times 5x minus 2x squared to the power of negative 1/2 plus f prime was 2x, or sorry, pardon me, 6 minus 6x times 2x minus x squared, and that's all multiplied by g, which was 5x minus 2x squared to the half power. Okay, we're not going to bother taking out any, that's what y prime is. So that'll be a chain rule with a combination, like a product rule or whatever. And I will get you to leave it in factor form. You don't have to do common factor or anything like that out front of it. So that's question number 3. Question number 4 is an implicit differentiation question. And that's worth 4 points as well. So question 4 is an implicit derivative question. 4 points. Okay, so something like find the derivative of, let's say we had x squared plus 3x cubed y squared minus 8 equals 0. Or let's equals 8, we'll say. Or like that, doesn't really matter. Okay, so when we're doing, we have to do implicit differentiation. So this would be 2x plus, and then we have to do product rule. So the product rule is f g prime plus f prime g. So let's just do it in our head here. Let's say that this is our f 3x squared, and we don't have to worry about putting in brackets here because there's a plus sign out front. But if there wasn't, we put it in brackets here. So this is going to be 6, or f, pardon me, not 6. F is 3x squared. And the derivative of this is 2y y prime plus f prime, which would be 6x plus g, which is y squared. And derivative of 8 is 0. And derivative of 0 is 0, so equals 0. So then we have to take this to one side and this stuff to the other side. So then we have, let's 3x squared, or let's multiply those 3 and 2 together there. I didn't see that. 3 times 2 is 6, so we get 6x squared y prime. Okay, we're going to subtract 2x, and we're going to subtract 6x y squared on the other side. So then we do 6x squared y, 6x squared y. Now we can reduce a 2 out of all of them, and we can reduce an x out of all of them because of the way it is set up here. So y prime equals negative 2x minus 6x y squared over 6x squared y. So let's reduce that. We can take a 2 out of it, so negative x. And, we can take an x out of everything as well. So we can make negative 2x there, negative 2x there, and negative 2x there if we want. Or say 2x out of everything, so we'll leave it as negative. So negative 1, and this would be minus 3y squared. And then a 2 out of this one here would be 3xy. That's going to give us our prime. So we'll have an implicit differentiation question. And our final question is a slope of a tangent line question, worth 4 as well. So question number 5. the slope of a tangent line. So you could use any of the derivative rules here. Type question. Okay, so this is going to be worth 4 points as well. So let's do an example. Find the equation of a tangent line to the curve y equals negative x cubed plus 3x squared plus x let's see, minus, let's see what I want, 1 minus 2 at x equals 1. Okay, let me fix this up. So we get the square and the cube in here. Okay, it could be a polynomial curve. It could even be an implicit curve. I might give you a circle or something too, so you don't forget to study the implicit circle or ellipse type one that we did a couple days back. Or it could be a quotient rule or a product rule, but I'm just going to do the example here. It's just a polynomial rule. So the first step is to find the point. So what is our point? Okay, remember with the circle and the ellipse one, it'll give you a hint of whether to use a negative or positive y value that comes out, because sometimes it's y squared, right? So keep that in mind. This time we don't have to worry about it because y equaling something. So we just plug in 1. So y equals negative 1 cubed plus 3 times 1 squared plus 1 minus 2. So this is negative 1 plus 3 plus 1 minus 2. So we've got 2, 3, because those cancel out minus. So we've got 1. So our point is 1, 1. Okay, and then we get the slope. So we take the derivative, which represents the slope. And then we're going to plug in x equal 1. So the derivative of y prime is going to be negative 3x squared plus 6x plus 1. And the derivative of negative 2 is 0. Okay, so then if we want to get the slope, which represents the derivative, it's 3 times 1 squared plus 6 times 1 plus 1. So we've got negative 3 plus 6 plus 1 equals 4. So our slope is 4. Okay, and finally, we then use the equation of the line to calculate or find the line. So this is where y minus y1 I didn't put on the formula sheet, so hopefully you added it. Okay, so our point is 1, 1. So y minus 1 equals 4 times x minus 1. Y minus 1 equals 4x minus 4. Let's bring everything to the left. Y minus 4x, add 3, or add 4 plus 3 equals 0. Okay, and that is the quiz. Okay, 25 points. Those questions here. This is question number 5, by the way. And that quiz you'll write when you're ready for it, and yeah, but don't wait too long. Okay, and of course you can bring in your formula sheet, or maybe I'll send it with the exam that looks like this. I'll add on that extra part here of y minus y1 equals m times x minus x1 for the line equation, in case you forget it. Okay, so that's it. Good luck on your exam, and we'll see you next unit.